Hey guys, today we're going to solve LeetCode number 1568. It was featured in today's contest. It was the third problem. So we're given a 2D grid of ones and zeros. The ones represent land and the zeros represent water. And an island is a 4-directionally connected group of ones. This is extremely important. We cannot go diagonally. Now, this is kind of a weird definition, but we're going to go with this. The grid is connected if we have exactly one island. So we need to return the minimum number of days to make it not connected. So to have either 0 islands or more than one island. In one day, we're allowed to make one land cell into a water cell, but we can do the reverse. We can't take a water cell and make it a land cell. So this problem, the key insight to solve this problem is you can do some trial and error. Like, one of the things that is really helpful is take this example and fill in all of the zeros with ones. So now you have a completely filled with land matrix, and you need to ask yourself, okay, what is now the minimum number of days that will take me to make it disconnected? And the first thing that I thought of was, well, here I only have 2 lands, so I can disconnect like this. So then I coded up a solution that went through all of the columns and all of the rows and checked which one was the one which had the minimum amount of ones. So those were the ones that I wanted to turn into zeros. But that is not the best thing that you can do. The best thing you can do is just remove, for example, this and this lands, make these zeros, and that will make this one an island by itself. So what this tells you is that no matter the configuration, the maximum amount of moves that you need to do to make it disconnected are 2. Because the worst thing that can happen is you have some island and the best thing that you can do is this one. So this is the worst case scenario. And so we only have then 3 answers. The first answer is if the grid is already disconnected, like in this case, then we're going to have to return 0. The second case is the island is connected as of right now, but there is one cell that can be turned into water to make it disconnected. And so in that case, the output would be 1. And in all other cases, the output is 2. So that's how we're going to do this. So in this video, it's not going to be as usual where I paste in line by line. I'm just going to paste it all. So this function here is an helper function that we're going to use. And I've already talked about the problem of counting the number of islands in a grid. I have a video about that already, so I'm not going to talk about this. It's just a depth-first traversal of the grid. And instead, I'm going to focus on the part that this problem is about. So the first thing that we do is we check if it's already disconnected, just return 0, because we don't need to take any days at all, because it's already disconnected. Now what we're going to do next is we're going to go through all of the cells that are representing land, and we're going to make them water and check if now the amount of islands is different than 1. And then if it is, then we know that removing this piece of land will make it disconnected, because the amount of islands is different than 1, which is the definition of disconnected. So we can return 1, because in one cell, modifying one cell allows us to make it disconnected. So we only take 1 day. And remember to restore the grid afterwards. If this is not the case, we're going to have to return the grid to its original state. So this is done for all the cells that represent land in the grid. And if none of those cells make it so that the number of islands in the grid is different than 1, then it means that we are in the worst possible case, meaning that we need to take 2 days to do so. Yeah, so that's it. I'm going to submit the solution to show you that it works. And actually, this algorithm is not optimal. There would be a better way to do it. This is the time complexity of this is n squared, where n is the amount of elements in the grid. And we also take n squared memory, because we clone the grid every time that we check the amount of islands. And so, yeah, the optimal solution would be O of num of rows times num of columns, which is just O of n, where n is the amount of elements in the grid. But this is the intended solution for this problem, because it's considered a medium one. If they wanted us to do the O of n solution, this problem would be hard. Okay, so that's it for now, and bye.